Lab 38 is called SWAP, and it is our first lab that requires us to use reference parameters. So up until this point, we've defined functions using pass by value, and now our parameters need to be defined as pass by reference. In this assignment, we have in your template window a fully functional program, and it has a function in it called swap wrong. Now, swap wrong is called swap wrong because the purpose of this program is to read in two values into x and y. And as you can see in the sample input here, we're reading in a 3 and a -7. And then we want to swap those by calling the swap wrong function. All right, so before swap wrong, x equals the value in x, y equals the value we read into y, and two end else. So that's this output right here. Before swap wrong, x equals 3 and y equals -7. All right, in line 19, we call the function swap wrong. We pass x into the first parameter and y into the second parameter. So let's go look at what swap wrong is actually doing. In swap wrong, we have two parameters defined, a and b. So x, the value of x is passed into a, and the value of y is passed into b. All right, then we output in swap wrong, then we output before swap a equals a and b equals b. Let's go look at the output. In swap wrong, that's the first cout statement, and then before the swap, a equals 3 and b equals -7. That's because we read the 3 and the -7 into x and y, and then we pass the value of x into a and the value of y into b. All right, now in line 31, we are creating a temporary variable called temp of type int, and we're assigning it the value of a. So remember, a has a 3 in it, right? In line 32, we overwrite a with b. So because we temporarily stored a in temp, we can now overwrite it with b. So now a has a -7 in it. And now b gets the value of temp. So b now has in it the 3. So we've actually swapped the contents of the memory locations A and B. That works. And then we output after swap A equals A and B equals B. So if we go back up to our output, we see after swap A equals a -7 and B equals 3. So we properly swapped A and B. But when we hit the close curly brace and go back up to the statement that follows our function call, here's our function call, that is a cout statement. Now remember, the purpose of this program is attempting to swap x and y. So after swap wrong, we output x equals x, y equals y, and then two end else. That's the statement right here. Notice x and y didn't get swapped, right? That's because we passed x into a and y into b by value. These arguments, x and y, were passed into the parameters by value. So remember, when you pass by value, your parameters just get a copy of the value that's being passed in. It's a separate memory location. It's like defining local variables inside this function. So therefore, when we return, x and y are still the exact same values they were before we called swap wrong. So that is why we're outputting here the x equals 3 and the y equals -7. Your job is to write a swap ref function. You're going to call your swap ref right here, and then you're going to output your values after swap ref. So in other words, just like we output the values after swap wrong, you're going to do the same thing. In fact, you can copy and paste this programming statement below this code, this comment in line 22, and change swap wrong to swap ref, and you're good to go. But let's first talk about call swap ref. All right, swap ref needs to be a function that you write that properly swaps the values that are passed into the parameters. I'm going to go back up to the programming assignment. It says Your job is to add a swap ref function that swaps the arguments correctly using pass by reference. The prototype of this function will be as follows. All right, so I'm giving you the prototype right here. You can take this prototype and use it in your program. So we're going to copy that and paste it right here so that we have our prototype. So now let's dissect this prototype. The return type is void. The name is swap ref. Get rid of this space. There should not be a space there. The name is swap ref. The data type of the parameters. Let's look at those data types. All right. Normally, when we were creating pass by value parameters, remember it's just the data type and then a comma. But notice there's an ampersand here. That is the sign that the ampersand is what we use to pass by reference. So this is an integer reference parameter that will be defined, and the second parameter will also be an integer reference parameter. Add the lines in the main function that will test this new function and show that it works correctly. When your input is as shown in figure 1, your program should produce the output as shown in figure 2. So right now, this program actually does all of this, right? And now we have to write the code that will call swap ref, and then inside swap ref, we need to output before swap, after swap, and then we need to add the code to output after swap ref, and this code, the line of code that creates this output will be in the main function. So let's first call swap ref. So if we call swap wrong in line 20 with x and y, and this was our attempt to swap x and y, but it didn't work, let's go ahead and call swap ref. And I know what swap ref looks like because I have the prototype up here. I'm going to call swap ref with x and y. And then I set to output the values of x and y after the swap ref. Well, you need to create this line of output right here after line 24. So I'm going to just copy and paste the after swap wrong line of output because it's very similar. The only thing we need to change is that we are outputting x and y after swap ref, not after swap wrong. So let's just change that to after swap ref and we should be good to go. All right, so when swap ref is called in line 23, control transfers to the function. Well, that's the part that isn't written. It says add your swap ref function here. So we already know what the function header needs to look like based on the prototype. It has a void return type. The name is swap ref. It has two integer reference parameters. And we're going to call them A and B because that's what we call them in swap wrong. So we can go ahead and write our function header, and it's swap ref as the name. And then the actual names of the parameters can be A and B. But what's important is that you put the ampersand in the parameter list. Now that ampersand could be right beside the int, like I'm typing now, or it could be right beside the actual parameter name. So it can be by the data type, that ampersand, or it can be by the actual parameter name. So either one of those will work. Now remember, you always need an open close curly brace to block your code, and inside that open close curly brace is the body of your function. Well, swap ref is going to be very close to swap wrong. So what we can do is take our swap wrong code and paste it into our swap ref function, and then change what is necessary. We're not in swap wrong now, we're in swap ref. We're going to be outputting this. So in swap ref, change swap wrong to swap ref. And then before the swap, A equals B equals, this is good code. This swap, remember last time I walked you through this actually swaps the contents of A and B. And then after swap, well, that is this line of code, and it actually works correctly. So what is different? Why is this actually going to work when swap wrong didn't work? I actually just copied and pasted swap wrong's code into swap ref and changed the word swap wrong to swap ref. I haven't changed any of this. So is it actually going to work if I run the program? Let's see what happens. All right, before swap wrong, x is 3, y is a negative 7. After swap, this is what's output inside swap wrong, right? We went over that earlier, and then after swap wrong, x is still 3 and y is negative 7. Here's what our swap ref is actually outputting in swap ref, and then once again, the swap worked correctly in swap wrong, so it's still working correctly in swap ref. What's important to see is this line of output is different. After swap wrong, x was 3 and y was a negative 7. After swap ref, x is a negative 7 and y is a 3. It actually swapped the two values in x and y. Why did this work? Well, it's because we used reference parameters. So the difference between swap wrong's parameter list and swap ref's parameter list is that swap wrong has passed by value, swap ref has passed by reference. Because we pass by reference, we're not passing a copy of the x and y into the parameters a and b. We're actually passing a reference to where the argument is in memory. So here, when we pass x into the reference parameter a, we're passing the address of where x is in memory. So whatever we do to a inside the body of this function, we're actually doing to x. Likewise, we're passing y into the reference parameter b. So whatever we do to b, whatever changes we make to it, we're actually changing y's value in the main function. So when you pass by reference, think of it as passing an address of an argument. Whatever you assign to the parameter inside the function will actually modify the original argument's values. I've written this program for you, but it was so that I could explain the difference between pass by value and pass by reference.